Welcome back to another episode of our STEM Virtual Experiment Series. I am Xavier Murray, a Technical Information Officer of the Scientific Research Council. Today, I'm joined with Mr. Alexander Okwangai, chemistry tutor from the Moran Bay High, and Joseph Odo.
Glad to be here.
Today, they will be exploring Avogadro's law.
Avogadro's law looks at the relationship between the volume of a gas and the number of moles of that gas. And the relationship is such that the volume of a gas is directly proportional to the number of moles at constant temperature and pressure. Another way we can say is Avogadro's law is by looking at the fact that equal volume of gas contain the same number of molecules. So it is expected that if the volume of gas increases, the number of moles also increase. And in this experiment, we will be looking at the reaction between acetic acid and baking soda. Acetic acid, as we know it, is ethanoic acid, which popularly we call vinegar at home. So the reaction is indeed between vinegar and baking soda. Baking soda here is sodium hydrogen carbonate, is a salt. So haven't got the reagents, we are going to look at different masses of baking soda in the order of 4 grams, 8 grams, 16 grams, and 32 grams, measured in that order and placed in a balloon. And the acetic acid is 5% acetic acid reagent. And we're going to measure 190 mils of acetic acid into each of the 5 conical flags that we have set up. As the reaction proceeds in earnest, what we will do to start the reaction is now place carefully the sodium bicarbonate in the balloon neatly over the mouth of the conical flask that we are using, and ensure that none of the particles of sodium carbonate enters the acetic acid because the reaction have not started. Once that is done, we are now ready to start each of the reaction at 0 time. We carefully raise the balloon such that the salt, the sodium carbonate in the balloon, is emptied into the conical flask containing the acetic acid. And the reaction begins when the acetic acid or vinegar begins to react with the bicarbonate.
Joseph, Mr. Okwangai mentioned moles of gas. Do you know what a mole is?
A mole is a term that's used to represent an amount of substance that contains about 6.022 times 10 to the 23 particles, which is Avogadro's number.
Excellent. Thank you very much. So, gents, I will leave you to do your experiment.
During the first step of the procedure, we were able to measure 4 grams, 8 grams, 16 grams, and 32 grams of the baking soda and empty it separately into each of the balloons. The second step of the procedure, we are now going to measure 190 mils of the vinegar into each of the conical flags. Once the adequate amount has been measured and transferred into each of the conical flasks, we are now going to take the balloon and its content in such a way that the tip of the balloon is placed over the mouth of the beaker and ready to commence the third step. Now we are about to commence the fourth step of the procedure, which actually now entails reacting the baking soda with the vinegar in the conical flask. It is important to note at this point in time the variables that are in this experiment. If you remember, we measured 190 mils of vinegar into each of the conical flasks. Because the volume is the same, the variable is known as the control variable. So the control variable for this experiment is the 190 mils of vinegar in the conical flask. The next variable is the manipulated variable. And the manipulated variable here is a different amount of baking soda that is measured for this experiment. And the amounts are 4 grams, 8 grams, 16 grams, and 32 grams. That is the manipulated variable. Now, the responding variable is what we are going to find as we react the baking soda with the vinegar. The responding variable will be the volume that is observed when the carbon dioxide coming from the reaction inflates the balloon. So 3 variables: control variable, 190 ml vinegar in each of the conical flasks; manipulated variable, the various amount of baking soda in the balloon; and the responding variable, the volume of gas that is formed in the balloon. Joseph, as the experiment proceeds, what would be your expected observation?
Well, I believe since we put increasing amounts of baking soda in each balloon going up and same volume of vinegar in each beaker, when we actually tip the baking soda into the beaker, I believe we'll see increasing amounts of gas being produced in the beaker, producing the balloon as we go.
You can just see that.
So let's see if that's correct.
Wow, this is great. Wow, just look at the balloon. Wow. Okay, the reaction seems to have stopped. You see the bubbles is going down. That means the gas production. Okay. All right, let's note this. Do the second one.
Okay, interesting results. Not exactly as I expected. I assumed that the amount of gas we get in the balloons would increase going up, but looks like for 16 and 32, they're about the same. Can you explain why it is?
Yeah, for 16 and 32, the observation is very correct. The reaction have reached its equivalent point. As you will know, this is a typical acid-base reaction,
Right.
and the amount of vinegar available for the reaction was exhausted at 16. So the 32 do not have more vinegar to create more volume.
Right.
So the vinegar in this case is the limiting reagent.
Okay.
So at 16, the reaction reached its equivalent point.
Okay. So what does this have to do with, Avogadro's law and moles we were talking about earlier?
All right, so we can consider the first, second, and the third experiment. And we clearly see that as the amount of baking soda used increases, the amount of gas produced increases.
Right. This is what I thought would happen.
Yeah, and that is typical for the first, second, and the third experiment. Because there is limitation in the third experiment, you would not really observe that continuous increase further than 16 grams.
Right.
The experiment using 16 grams of baking soda and 32 grams of baking soda, it's true that they produce equal amount of gas, meaning that the amount of gas in terms of moles are just the same.
Right.
Well, that was a very enriching and enlightening experiment. Thank you, Mr. Akongai, for taking time out to explore Avogadro's law with us.
I'm happy to be here. Thank you.
Thank you for watching the video. Please make sure you like, subscribe, and share with all your friends. Please tune in for the next episode.
I thank you, and we'll see you again next time.